Okay, so rotation, everyone's favorite. In this particular one, we have this set up here of a torsion pendulum, and it tells us it consists of a disc with a rotational inertia I, and it's suspended by a flexible rod attached to a rigid support. When the disc is twisted through a small angle theta, the twisted rope exerts a restoring torque tau that is proportional to the following equation. Tau is negative beta theta. Beta is a constant, theta is the angle that's swept out in radians. The motion is, it says here, it's analogous to the motion of a mass oscillating on a spring. And part A wants us to write a differential equation that can be used to determine the angular displacement. So we have this wonderful torque equation here. Torque is negative beta, which is a constant, theta. We also can conclude that the summation of torques is I alpha, and there's only one torque present. So we could say I alpha equals negative beta theta. Well, how am I going to get a differential equation out of this? It's going to come from the angular acceleration alpha. Alpha is the second derivative of theta. So I d2 theta over dt2 is negative beta theta. Now, it asks us just to write it and not solve it, so I'm going to go ahead and stop there for part A. And let's move on to part B. Moving on to B, we're going to use the analogy of the mass oscillating as a spring to remind you the period of that oscillation will be 2 pi times the root of m over k. Well, this looks a lot more complex than it is based on this question. It wants you to know, determine the period of the torsion pendulum in terms of the given quantities, fundamental constants as appropriate. But it's an analogy, so it's not as bad as it seems. We're in rotation, so instead of mass, we use I, the moment of inertia, which is mass distribution. And instead of k, the spring constant, we're going to use beta, the constant that was given to us for this particular problem. At this point, A and B are golden. So let's move on to C. I'm going to have to go ahead and get this wonderful graph all nice and ready. Copy this and come back into here. Paste, success. Let's move D, E, and F out of the way. And it says on C, on the graph below, plot the data points, draw a straight line that best represents the data. Okay, so in order to do that, we're going to need the data table from up here. And our goal is ultimately going to be find, well, how do we get beta? All right, so let's see this little mix and mash of stuff up here. Period does not relate to I. Period squared, though, does relate to I. And well, why use period squared? Kind of cheated. I looked at the table and it gave me right here numbers for period squared. That was my tip off. Also, it labeled right here on the axis t squared and I on the x-axis. So this equation, though, is going to be important because, as you can guess, it's going to move you along to find out what happens to beta. I'm going to pause the video, make the graph, and then come back. So I've gone ahead now and made my plots and drew my line. I got 2 of the points above the line and 3 below, so not exactly perfect, but a pretty darn good line. Let's move on to D, E, and F. D says determine the equation for your line. Okay, so this is a line, which means that we have a y equals mx plus b kind of format. The y-axis is seconds squared, and the x-axis is kilogram meters squared. The y-intercept is shown right here. It is 2 seconds squared. So, what's the equation of the line? T squared equals 142 times I plus 2. That's your answer to part D. Part E, as I predicted, let's go find beta. So if we zoom out a moment here, and we see I made reference to this equation earlier, what I can say is T squared equals a 4 pi squared over beta times I. What this tells me is this has got to be my slope of 142. So I will go ahead and say beta, well, let me back up a quick second. 142 is 4 pi squared beta. Do a little bit of mathematics. 4 times pi squared divided by 142. Beta turned out for me to be 0.278, and the units for beta are actually going to be the reciprocal of the units for the slope. Remember, this 142 is 142 seconds squared over kilogram meter squared. Pi is dimensionless, 4 is dimensionless. So instead of seconds squared per kilogram meter squared, this would be kilogram meter squared per second squared. That's beta. So the last thing is, what is the physical significance of the intercept of your line with the vertical axis? If you take a look here, there was no y-intercept in the equation. We have to come back to the beginning, and the answer is hidden right here. The intercept is the square of the period of oscillation of the flexible rod itself. And hopefully that kind of wraps up this question for you.